Hi everyone, welcome to Master Lucas Academy. Well, once you see this type of problem and you see me home with my tie, just know that me and the problem we dey tight. Now, this kind of a problem given to you to solve is from the past question, and the question says the equilibrium constant for the reaction is 18.5 at 925 Kelvin and 925 at 1000 Kelvin. Calculate the enthalpy, that is the standard enthalpy of reaction. This one is your T1 and 9.25. This one is your what? Your K2, and this one here temperature 2. Okay, so the question asks you to calculate the enthalpy of reaction, the standard enthalpy of reaction. So in order for you to calculate the standard enthalpy of reaction, what are you to use here? So I will advise you to make use of this formula, very quick, fast, and reliable formula. So here you are going to have 2.303 followed by R followed by log of K2, take note of that, over K1, all divided by T2 minus T1, all divided by, which is you are going to have T2 times T1. Simple, very simple formula. There is no problem about that formula. So you now proceed. That is 2.303 times the value of our R, 8.314, times the log of K2. What is K2? That is 9.25 divided by, what is your K1? That is 18.5. All divided by your T2 is given to be 1000 minus your T1 is given to be 925 divided by 1000 times 925. Okay, so the next thing you are going to do now in this place is that you are going to look for the division of this one and find the log, which is 2.303 times 8.314 followed by times log of, if this divided is 0.5 divided by, when you subtract this from this, you have 75 divided by, this one will give you 925000. Okay, so what is log of 0.5? That should be 2.303 times 8.314 times what we call log of this will give you minus 0.3010 divided by, now when you use this one to divide this, what are you going to have there? 0.000081. that is the value for it. So the next thing is you are going to multiply all of them here. You are going to multiply all of them together. So by the time you multiply all of them together, you are going to have minus, that is 5, that is 57617 divided by this value 0.000081. So what will be the final value at the end of the day? You are going to have minus 71151. Divide this value by 1000. If you don't divide it by 1000, you are going to have joule per mole. Okay, but when you divide it by 1000, what are you going to obtain? That is minus 71.1 kilojoule per mole. That is what we are going to obtain at the end. So for the free energy, here we go. When the temperature is what? 925 Kelvin. So at 925 Kelvin, the constant is what? Is 18.5. So which formula are we going to use here? That means this now is equal to, where we are going to have our formula as R followed by, we are going to have T followed by, you make use of what we call ln. Take note of that. If you make use of ln, that will be ln of what? Ln of 18.5. So this formula is equivalent to, that is minus R followed by T followed by 2.303, then followed by log of what? Log of 18.5. That is what we are going to use there. So in accordance to this problem, here we go. Let's see whether we are going to be on the right path. Anyway, I'm using this one. You can try this one at your end there. So this one will be minus, that will be 8.314 times temperature at which is taking place, it says 925 followed by times 2.303 followed by log of 18.5. So after finding the value of log of 18.5, what does that result to? That results to the value of minus 8.314 times 925 times 2.303 times where we have 1.2671. So at the end of the day, what do we have as the final value? We have 22466.00 divided by 1000. So when you divide this value by 1000, it will give you minus 2.4, then approximately 7 kilojoule per mole there. Take note of that. So equals to okay, so in this place you make this one subject of the formula, this one here you make it subject. So when you make this one subject of the formula, what are you going to have? You are going to have, that is equals to free energy then divided by the temperature. So you are good to go. So the next thing we are going to do here now, you compute the data. So bring this one here, minus 22.47 followed by minus here, then this one in this place, minus 71.1. okay, so divide the value by what? By the temperature given. The temperature given is what? 925. So the next thing we are going to do, this become positive, minus 22.47 plus 71.1 divided by 925. So what will be the value of the upper one? The value of the upper one should be 48.534. You can check it out, should be a close value. Then you divide it by this one here, 925. What would that give you? That will give you 0.05249. Divide. Okay, so after obtaining this value, you are going to multiply by 1000. okay, minus 0.05249 multiplied by 1000. So why are we multiplying it by 1000? This one is already in kilo, this one is also in what? In kilo. So we have to multiply it, since we don't leave the unit of this one in kilo but joule per Kelvin. So multiply by 1000. What will be the possible value for that? So we are going to have minus 52.46 joule per Kelvin. So irrespective of the nature of the calculator you are using, make sure we get the value that is close to this one that we have here on the board. You must have at least 52 point something. Okay, so that is how to solve the problem.